All right, so as we can see on this lovely day, we are going to be using the distance formula in a variety of situations. So first off, we have to ask ourselves what the Gehenna is the distance formula, from whence does it come, and then we're going to apply it. So let's take a gander here. Plot the point 6, 8, and then we're going to calculate the distance from the origin, and origin means 0, 0. So let's see here. 6, 8 is somewhere about here. There we go. And you can't see my lines very well because of the projector, but you can hopefully see it on yours.
Lines?
You don't have, the copier didn't make them so well? Okay. All right, so we've got these two here. Now, it's not overly complicated to figure this one out because if you consider what we have here, we're talking about finding the distance between these 2 points. In other words, how long is this segment? Well, note we have 2 components to it. We have a height and we have a horizontal length. So what shape is formed here? More specifically, a right triangle. And there's no crazy work here. If we want to figure out how long each side is, the legs, all we have to do is count. This one starts at 0, goes all the way to 6. So the black horizontal has a length of 6. And lo mismo for the red. We go this way and starts at 0, goes all the way up to 8. We can see right there. So this one is 15. Just kidding. All right. And now, how do we find out the length of the blue hypotenuse? Chat with your neighbor, please. I'm going to call this D for distance, but you could have called it C for the standard hypotenuse. So now we can set this up. We know that we have A squared plus B squared equals C squared. And now I start to plug things in. A squared is 6 squared plus 8 squared is my unknown length, D squared, D for distance. And hopefully this is familiar to you. Many of you will already recognize this as a Pythagorean triple because the answer is 10. And when we simplify, we get 100 on this side. D squared here, and when you square root both sides, there is a positive and a negative answer mathematically, but distance is always positive. So the answer is 10. So notice what we did. We superimposed a triangle that wasn't there to begin with in order to find this hypotenuse. We just said, oh, we have a vertical component, a horizontal component, so if I consider those two, I can now use a Pythagorean theorem. All right, so this one here, as you draw this, make sure that you use straight lines because that's going to mess up your diagram and your counting. All right, so 3, 2 is here, and 9, 10 is here. So we've got this hypotenuse, and now I have a horizontal component that goes to here and a vertical component that goes to here. Now when I count this, you can just use the numbers along the sides to count. So here I start at 3, so don't say 1 here because that's a 0. 0, 1, 2, 3, 4, 5, and 6 to get to there. So this length is 6. Now when we start counting over here, we start at the 2. Start at 2 and we end at 10. So 2, so that's 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now what do you notice about the 2 triangles? They're effectively the same. One is shifted. We just, in starting point here, we just shifted it over to there. And it is the same triangle. So we actually already know what the answer is. No need to show any work. But the way we came up with the answer was slightly different. How? Because this one, my counting was given to me. The 6 was already here. I just wrote it there. The 8 was already here. I just wrote it there. This one over here, I had to actually count, beginning calling my 3 my 0 and counting. But notice here, I have a 9 there and a 3 there. How do I get 6 from 9 and 3? How do I get 6 from 9 and 3? 9 minus 3 is 6. Now, up here, we're at 10 and a 2. So how do I get 8 from 10 and 2? We subtract. So over here, if I subtract, look at what I'm subtracting, the 10 and the 2. Over here, what am I subtracting? The 9 and the 3. I don't even have to draw it. Thank you very much. As mathematicians, we say, Dag, that was too much work. Is there a faster way? And of course, we want to answer that question with a yes once we discover it. So, notice here, this note. One way to find the distance between any 2 points is to plot the points. Draw a right triangle and use the Pythagorean Theorem. Holy mushkama, there's so much going on here. Pythagorean, learn to spell theorem. And then we find the hypotenuse, or the length of the hypotenuse. In this case, the distance. So of course we ask ourselves, is there an easier way? Let's take a moment to derive Pythagorean theorem. Let's say you have some point here, and we don't know what it is, so we're going to call it x1 and y1. It's a first point. It has some x and some y. Now let's have another point up here. We don't know what that one's called, so it's some x and some y, but it's a different one, so that's why we have a 2 on that. So how do I find the distance between them? How do I find the distance between them? Well, again, note what is formed. We have a right triangle that is formed, like so. And in order to find the distance between 2 points, we just take our x here and our x here, and we subtract them, just like we did earlier. Right here, all I had to do was subtract the 9 minus the 3 would give me that. So we're going to take each part, and this one is simply here. We take our second x and we subtract our first x. That will tell you how long the horizontal is. So we are indeed going to write that down. y2, and let me use blue, y2 minus y1. And that's going to find that. So notice what's going to happen here. When I use Pythagorean theorem, which says this, c squared equals a squared plus b squared, I'm going to solve for c, but instead of calling it c, it'll be called d in just a moment. In order to get c by itself, I need to square root. So c here is equal to the square root of a squared plus b squared. Now notice here, how do I find the length of the horizontal? I subtract the x's. How do I find the length of the vertical? I subtract the y's. So if I substitute in, I get this. Instead of c, I'm going to call it d for distance. Instead of a, I'm going to write the subtraction. You just subtract your x's and square it. And instead of the b, I'm going to write the subtraction of the y's. Like so. And everything needs to be square rooted. Oops, and I forgot to put a square there. So this is your new best friend called the distance formula. So let's walk through it. Remember that every time you use it, please write it to help you memorize. So let's start by writing the distance formula. x2 minus x1 squared plus y2 minus y1 parentheses squared, and put the radical around the whole thing. Now, you do not have to draw these, but it might be helpful. Here is my second x, and I'm going to subtract that 2. So I'm just going to write it right there. I'm going to say 6 minus 2. I'll put that in parentheses, and I'm going to square it. Now I'm going to take my second y and subtract the 5. So 8 minus 5. Don't forget to bring down the plus, the parentheses, the square, and the radical. It is a lot, but only get rid of a symbol when you use it, like Kleenex. And please write everything down. A lot of us like to take shortcuts and just forget about things. Punch you in the neck if you keep doing that. Now from here, those two here become a 4 with a square on it. These two here become a 3 with a square on it. And folks, don't forget your radical. Now we simplify again. We get 16 plus 9. Don't forget your radical. Radical 25. And your final answer is 5. And we're going to set this up the same way. Please start with the super secret formula. x2 minus x1, all squared, plus y2 minus y1, all squared, and put a radical around it. Now, my x here, my x2 is negative 3, and I'm going to subtract a 2. So it looks like this, negative 3 minus 2. Put parentheses around that puppy, square it. Now, this one's a negative 7, and I subtract a 5. Negative 7 minus 5. Square that and radical around the whole thing. I like to put the radical at the end just to make sure that I have enough room for things. Now, this here becomes a negative 5. Keep parentheses around the negative, and I square. The blue here becomes negative 12. Parentheses around the negative, square it, radical around the whole thing. Negative 5 times negative 5 is 25. Negative 12 times negative 12 is positive 144. And lastly, I get the square root of 169, which simplifies to positive 13 is my D.